Um, Hi everyone, thanks for joining us and taking the time to be here. My name's Lucy, as Ralph mentioned. I am a aerospace and software engineer. I currently work at the NASA Ames Research Center, which is in Northern California. And I'm going to talk a little bit today about some of the broader work that NASA is currently undertaking. It's a very exciting time for NASA right now, and as well as then touching on some of the specific things, parts of the program that my team works on. And I'll tell you also a little bit more about myself in some of the slides to come. And then I'll finish it off. I have one slide about opportunities at NASA and kind of pathways to NASA for those who are interested in getting involved in some of the work that we do. So to begin with, let's see, yes, okay. I just put up a brief timeline of some of the significant events in NASA space exploration. I'm sure, I'm sure you guys are pretty familiar with the Apollo program. I know this was the thing that really inspired me when I was growing up, was seeing old videos of the first of Neil Armstrong landing on the moon. And I've included here a list of the spacecraft that they used to launch the Apollo program, so that you can kind of compare with this third column here, which is what we're using for the Artemis project, which is the current project that we're in right now. The main goal being to land the first woman and the next man on the moon in the next 4 years, and to kind of build up a foundational baseline for which to really start to have sustained human presence and human exploration in space. And then in terms of, Martian exploration, I'm also sure you guys are familiar with the Mars rovers that we have sent to the surface. I think currently Curiosity is the only one that is still operational. They've all far outlived how long they were expected to continue sending us information from Mars. But Curiosity is currently the one that's still active, and they're still receiving data from right now, today. And I think it speaks to some of the success of these rovers that we're sending so many more. You can see we've got one from China and one from the US to land early next year. And the European Space Agency is also working on their own to launch the following year, just to continue the legacy of unmanned exploration of the Martian surface, where we've really built up a lot of, there's mounting evidence that there maybe used to be water on Mars, which increases the likelihood that we could find evidence of life, which is really, really exciting. And so the other thing that this new information is kind of helping us with is that onwards from Artemis, we have the Gateway program, which specifically Gateway is a planned space station that they want to launch and have orbit the moon around the same time as we're starting to put humans back on the surface. And the idea is to start to establish the kind of architecture that we'd need for sustainable space exploration, with the idea that we could make it would help us make lots of repeated trips to the moon, and also with the longer term goal being potentially as a way to start to sustainably have human missions to Mars. Humans, obviously, they're a lot more flexible than the unmanned rovers that we send, and they're able to, like they did in the Apollo program, collect materials from the surface and bring them back for study. So there's a huge push to start human missions, and we'd expect to learn exponentially more as we start to push towards that. Yeah, and now I'm going to segue into some of the work that my team does to kind of help this effort. So there is a lot of work going on, really exciting in the field of space exploration for the Artemis program, and some of the other work that my team does, it's very involved. I like to say that we're looking at the next big push in space, which is, you know, human exploration of our solar system, but also the next big push in aeronautics. So you guys may not be super familiar with the acronym UAM. It stands for Urban Air Mobility. It's just kind of like an umbrella term for anything that involves autonomous and electric and small scale aircraft that will be used for like intercity travel. And I think NASA's placing a fairly big bet that this is going to be like the next big thing in aeronautics, particularly electric and autonomous. And so they're looking at how to integrate the infrastructure that's needed to support those kinds of air vehicles into our cities, looking at vertiports and routing and air traffic and how to manage all of those things. With the other push in aeronautics being in air traffic control, which I guess traditionally like is not something that you would immediately tie with NASA, but NASA actually has a significant amount of collaboration with the FAA, where we look at commercial air travel and air travel planning, airport planning, and basically how to make all of those operations safer and more efficient. And so yeah, my team does a fair amount of work in those areas. And then, so specifically for the Artemis program, we have, so one of the facilities that my team runs is a large motion simulator. And the reason that this is important is because so NASA has contracted out the building and design of the lunar lander to 3 companies. And the thing is, it's like when you design a lunar lander, it's extremely difficult to test because there's no way to really replicate the lunar environment on Earth. I mean, like you can't just like dial back gravity or get rid of the atmosphere. And so, you know, even in the 60s when they were developing lunar landers, the amount of testing and astronaut training that they were able to do is very limited. Actually, there was like one story from the 60s that they did that I think you can still see in JPL. They built this wall that was tilted, like slanted at a certain angle against the ground, and they would have the astronauts in their harnesses like tied to a rope that was tied to the top of the wall, and they would have the astronauts walk along that wall, and it was at such an angle that the amount of gravity that they felt against the wall was 1/6 of the Earth's gravity, and that's how they tried to climate astronauts to the feeling of, you know, a lower field of gravity, and that's how maybe like they tested yeah, getting used to it and their spacesuits and so on. But for a vehicle, for a large vehicle, that's much more difficult to replicate, especially when you want to like astronauts want to try out the controls, and there's really no way of like replicating that in a large field on Earth. And so we use a simulator to get as close to that as possible. And the simulator that we work with was built in the 80s, so it wasn't it wasn't part of the Apollo program, but the plan is to have it be part of the Artemis program, where the 3 companies who are designing lunar lander vehicles can kind of like test out their dynamics and their control systems. And then further along the line, once the design has been selected, astronauts would be able to enter our simulation facilities and really train in a high fidelity environment, such that when they're actually landing on the moon, it isn't, you know, for the first time, which is really pretty similar to what Neil Armstrong did, which, you know, is exceptional when you think about it, but definitely increases the risk. And so that's where the simulator kind of helps. And then the last thing I have on here is probably what I spend most of my day-to-day on, which is the Space Launch System. This is a super heavy lift rocket. I think it's actually the most powerful rocket that NASA has ever developed. And this is the main launch vehicle for the Artemis program. So it has kind of like 2 main nose designs, one which is to support like a crew, and the second which is to support bringing like cargo and payloads up into space. And so one of the things I specifically work on is in order to study the behavior of the rocket through launch, we have created a scale model, like a smaller metal model of it, which we've put in a wind tunnel, and then we've cranked up the airspeed all the way to what we would expect it to be through launch. And we are studying like the forces that get exerted on it by the airflow and like the pressure that acts over different parts of the rocket body. And so, yeah, last year we ran one of these tests. We collected a ton of data, and a lot of my day-to-day is in looking at the data analysis, seeing if we can parse out the aerodynamic behavior of the airflow over this vehicle, and seeing if we can get insights into its behavior through launch. So that's pretty cool. Yeah, okay, so I think the next thing I was going to talk about, yeah, is a little bit more of an introduction. I should have probably put this a bit earlier, but as I mentioned before, I'm an aerospace and software engineer. I actually work at a contractor at NASA Ames. I'll explain what this means in a bit more detail in a minute, but basically it means that I work for a company that does work for NASA Ames as opposed to working for the government, working for NASA directly. And in case it wasn't obvious from the accent, I grew up in the UK, and that's where I kind of really started learning about physics and kind of having a passion for physics and maths. I like super nerded out on the Apollo program and space exploration, and yeah, from like being around maybe you guys' age, like in middle school, I decided that yeah, this was like really interesting stuff, and I wanted to be a part of space exploration. And so I came to the US for the first time to do my undergrad. And then when I graduated, I think I struggled a little bit with directly finding a job that was relevant. And so I actually spent my first year after graduation consulting in San Francisco for a technology company. But I'll be straight up and admit it, like that didn't suit me at all. And I studied mechanical and aerospace engineering, and I really did want to find a way back into a job that would involve engineering in the day-to-day and ideally like work towards some kind of like research related stuff. And so after a year in that job in consulting, I started trying to look for other opportunities, and I was very lucky that well, A, that there is a NASA center nearby, and B, that they had some positions open that I managed to work my way into. And so I've been at NASA Ames now for two years. In that time, I've managed to get my master's degree part-time. NASA's pretty good at supporting further education. And then yeah, I guess I have I have a square here about stuff I like. I think from looking at that list, it's pretty clear. It should be pretty clear to you why I moved to California and why I have no plans to leave. But yeah, so that's been pretty fun. And then, okay, so the last slide I have transitions a little bit. So I know you guys are mostly in school, and you're obviously like very interested in NASA and what we do. And so I have one slide here about potential pathways into NASA careers, and just like maybe some pieces of advice for those of you who are thinking of looking like now and also down along the road. And so I guess like to start in the most obvious place, NASA has internships, lots of programs for school-aged students as well as college-age students, community college, a few like diversity and the outreach programs, as well as, you know, regular just HR jobs that are posted they mostly use, I think, a government website called usajobs.gov. And I guess the main thing with this is, well, beyond the internships and the programs, which are kind of a bit more regularly scheduled, the job searching in particular on this career website, and I mostly speak from my own experience when I was looking, is that these can often work on very long timelines. Like it's not unusual for it to take on the order of like months, even more than like 6 months for someone to get hired. And I think that's just a case of the government being a bit bureaucratic and slow, and that's just kind of like the way things work. I think the internships and the school programs have a more like structured turnaround. Um, and so and these are also really good to kind of like get a foot in the door, like kind of get a sense for what working at NASA is like, and trying it out. So I would definitely recommend looking into those programs if they are available to you, if they're an option. Um, Particularly in looking for jobs, as much as it may suck, the importance of networking is definitely more crucial than you would otherwise think. I think the importance of like having a human connection with someone in NASA who maybe can, if not like directly vouch or advocate for you, is like familiar with the fact that you are a smart, driven person who's really passionate about the work that NASA does. That goes a very long way. The thing is, like with especially with USA jobs, and also even with internships and even with programs, is that like when you apply to them and you put your resume in, you're putting your resume in with hundreds, maybe thousands of other people who are also, very passionate and very driven to try and work for NASA. And sometimes it feels a little bit like, you know, the you're just like one in as a part of a very large crowd. And so if you have some kind of connection with somebody, then that's actually like that can actually be a very powerful thing to work in your favor. And the thing is, it's like you don't have to have a connection that exists like that. Maybe one of your family works for NASA, but I would encourage one thing that I did when I was job searching. I would encourage you to do is like reach out to anyone, definitely anyone you know who might work at NASA or know someone who works at NASA, but also like cold email people, reach out, like show interest in their work, show interest in learning what they do. And I think people are fairly open to sharing their work, especially with passionate young people. So I think, even if they don't have time or they never get back to your email, like you have nothing to lose by trying to reach out and just showing that interest. And I think that often will work in your favor. Um, One thing, like slightly kind of on the logistical side of things, is like locations. So NASA has a set number of centers that are like spaced around the US, and different centers have different strengths. So where I work at NASA Ames, we're probably the premier supercomputing facility for in the whole of NASA. And so there's a lot of work that goes on with parallelized processing and large scale simulations and that kind of thing. In JPL, they're at the forefront of space exploration. I think JPL is where most of the Mars rovers have been built and designed. And I know that I think Langley in Virginia has like the most powerful wind tunnel, for example. So there are different centers that have different strengths and different, they work on different fields within the whole kind of space exploration endeavor. And so that's also something to keep in mind. And the other thing is that, especially with everything that went on in 2020, most NASA centers at this point have shifted to a large portion of their workforce doing remote work. And so if it's possible, like if you're more interested in software or data analysis or those things that can be done remotely, you don't have to necessarily be tied to a center location. Although if it's in like hardware and building things, then that's a little bit different. And those people are actually mostly designated critical, essential workers. Mission critical, I think is the term, and they are allowed on campus under controlled conditions to do their work. Another big thing is that, so as I mentioned earlier, I work for a NASA contractor, and this I think is something that maybe people are less aware of, which is that NASA does a lot of its work itself, of course, with government employees and researchers, but it also has a significant ecosystem where it puts out work for companies to bid on, and in this way they hope that they get they can supply, like these companies can supply a bit more of a either like niche knowledge or experience that NASA wouldn't otherwise be able to source from within itself, and it allows it to be a bit more flexible. And so a large another way of getting like involved in the work that NASA does is through these contractors, and because each contractor is unique, like they have their own company operations, it's less kind of like monolithic as other than compared to the NASA program, NASA like job application process. And so obviously it depends on each individual contractors, but there are generally some trends that you'll see going through contractor hiring versus civil service hiring, which is that contractors, because they tend to be like smaller companies, they have their own kind of HR departments, they tend to be less bureaucratic. The turnaround with, you know, getting a response back from your resume, getting interviews tends to be quicker. The other thing is that in general, they will offer a higher salary than public service salary, but in return for that, there's generally fewer benefits, maybe potentially less job security, although it kind of depends on the way that NASA, how Congress decides to fund NASA year to year. But the other thing is that they also tend to be less restricted, again, by like NASA red tape and security stuff, and so they tend to take more non-US citizens. Whereas I think NASA is a bit more strict on that. There's a lot more like bureaucratic hoops you have to join. You have to jump through if you want to join the civil service as a non-US citizen. And the other thing is, the other big thing is flexibility. I think in general you have less flexibility as a contractor. You kind of do what the company needs, whereas as a civil servant, you might have a bit more say in what you're interested in. Although again, this depends from like contractor to contractor. And then the last thing that I put on here is that, you know, NASA is definitely a huge, huge part of US space exploration in general. But there's also a lot more going on. Like since the 60s, I think, where NASA was really the one like pushing through a lot of the space exploration innovation. Compared with then, like now there's a much more diverse set of opportunities. And many different players kind of involved in the game. So I'm sure like a lot of you guys have heard of SpaceX, maybe Blue Origin. Beyond these like more familiar names, there are also a ton of startups, university groups working on different aspects of space exploration. And the thing with these, especially with startups and university labs, is that they are also global. Like they're not confined to the United States. And obviously also beyond NASA, you have like the European Space Agency, the Canadian, the Japanese. There are many space agencies around the world that work on very important aspects of space exploration as well. And so yeah, definitely like NASA's not alone anymore. Like we've got a lot of partners. A lot of our work is in building and maintaining partnerships, you know, and like collaborating across different global organizations to bring space exploration to happen. And yeah, I'll just say, you know, a lot of these different opportunities look quite different to NASA. So particularly for startups and SpaceX and those companies, they may look a bit more like NASA contractors and less like working for NASA. So these are also a lot of like a wealth of opportunities to look into.
Do you mind if the students ask questions?
Yeah, absolutely.
Okay, so this is Aurora in Italy. Aurora, you should be able to ask your question.
Okay, thank you. Can you hear me?
Yes.
Okay, my question is, have you seen the movie Hidden Figures that talks about the 3 African-American women who participated in sending the astronauts to the moon? And I wanted to ask you if you have any opinions about it.
Yeah, I actually loved Hidden Figures as a movie. And if any of you haven't seen it, thanks for the question, Aurora, by the way. And if any of you guys haven't seen it, I would absolutely recommend it. It's really excellent, I think, and very much highlights the way in which certain groups have been kind of like made invisible in NASA's history. You know, one of the things that we don't often talk about when we talk about the Apollo program is that we sent 12 astronauts to the moon, and they were all older white men, right? And like behind that, there were, you know, I guess like diversity wasn't as much of a topic back then, but behind it, there were a diverse array of people who were very responsible for that effort. And I think especially now, I think NASA has a much greater awareness of the importance of diversity and inclusion. We have, as I mentioned before, we have a lot of programs that kind of try to help or provide more exposure to NASA to people who may not have walked a more traditional path. And I think it's really, really important that we continue to acknowledge the contributions of those people and also their potential to contribute in the future to space exploration. And yeah, I would absolutely highly recommend that movie. And I would also just like say personally, like from my perspective, yeah, personally, I have also encountered some of these things, like as a woman of color. You do, it's kind of somewhat unavoidable that you will experience like some of these microaggressions, some of these stereotypes that try to, you know, define or limit your potential. And I hope that, you know, people who can watch movies like Hidden Figures, I'm hopeful that, you know, the new generation will be able to have a much more, will have more sources of representation and empowerment and just advocacy, and also belief in yourself that, you know, it is possible, and you should absolutely not let other people's like biases or opinions stand in your way. Thank you for that question. I think it's super, super important, and it's something that I'm also personally very invested and passionate in.
Great question and great answer. We have a question from Luis in France. Luis, you should be able to unmute yourself.
Okay, can you hear me?
Yes. Hi,
Okay.
Louise.
Hi, thank you so much for being here first. And can you tell me, is it hard to be a woman at the NASA?
Yes. So actually, there's a funny thing that always comes back to me when I get asked this question, which is that one time when I was reading this article from the BBC, and it was about women, you know, who are making it in male-dominated fields, and NASA was actually one of the workplaces that was featured. And it was funny, this article was written, you know, just last year, like or a couple of years ago in 2018, and they were talking about, you know, NASA, particularly in the 70s, when I think it was much more of a male-dominated environment. And one of the examples they used was that there weren't really women's bathrooms, because no one expected women to work on NASA. And so when women did work in a NASA center, they would often, I think this was also in Hidden Figures, like they would also have to either like go extremely far away to find a bathroom that catered for them, or I think what happened slightly later was that NASA would start to convert men's bathrooms into women's bathrooms, and they would just like put a curtain over the urinals or something like that, and then just convert it into a women's bathroom. And the reason that it really made me laugh is because it's 2020, and that exists in my building. Like the women's bathroom that we have on the floor below has a curtain which has urinals behind it. And like, obviously, like it speaks to a little bit about how that infrastructure, the bathroom infrastructure itself, was so entrenched, but also I think it's a good analogy for the way that the culture is so entrenched. Like it's shifting, it's moving slowly. Like NASA itself has done a lot to try and be more inclusive and more gender equitable, as along with the whole field, I think, of STEM. but I think it is hard because like those things are still there. I'm very glad that the dialogue seems to be shifting, especially like the younger people seem to be particularly aware of it, and you'll often get you know, you can kind of see where people land on the on this question. Kind of it matches like their age range, right? So, but I'm very hopeful that because the dialogue is so much more aware these days and it's so much more widespread, I'm very hopeful that change will come and it will be exponentially improving just because of all of the dialogue and awareness of it. So I would say like I wouldn't say it's not a problem at all, but I would say it's definitely improving, and I would encourage especially like everyone here to you know, to never limit themselves by it or by other people's belief systems.
That's awesome. We'll go with like maybe a couple more questions, then we'll let you go. So we have a question from Marcos in Spain. He has a pretty good question. Go ahead and unmute yourself, Marcos.
Yeah, so lately I have questioned myself, do I want to be an aeronautic engineer or do I want to be an aerospace engineer? So my question is, what's the difference between them?
Okay, that's a pretty good question. I would say they share a lot of background. So if you're choosing a field to study, I would say actually there's a decent amount of overlap there. A lot of the fundamentals, like in maths and physical understanding, will actually be the same. And I think a lot of, yeah, I think in general, either of them is a pretty good pathway into the kind of work that NASA does. Maybe the main difference between them is in, or at least from what I understand, is that aeronautics is kind of the one half of aerospace, if that makes sense. Aerospace kind of encompasses aeronautics and space, which are two different things. Because if you're looking at vehicles that fly through the air versus vehicles that launch into space, you have very different designs, right? Like those vehicles are very differently shaped depending on whether you just want to get through the atmosphere or if you want to actually use the atmosphere to progress or to fly. And so aerospace is probably like the combination of kind of both of them, whereas aeronautics is more focused on the one side, like let's look at plane behavior and, you know, lift versus drag, and less about maybe like orbital dynamics and launching propulsion systems, that kind of thing. So yeah, I hope that answers your question. I think that's probably like the main thing that comes to mind for me.
That was a good answer, good question. We have Mies from, I believe, Catalonia. There you go.
Hello. Do we need good grades to join NASA? Or
good grades never hurt. I would say, yeah, it's tricky because I think it somewhat depends. But I would say, I mean, definitely good grades never hurt. But if you're looking at a situation where maybe your grades aren't as high as you would like them to be, I would say that they could be offset by good experience, obvious potential, and I think the way that you kind of project potential is mostly through ideally through interfacing with people. So if maybe you're a bit worried that your qualifications on paper don't like make you shine, then I would come back to the second bullet point on this slide and say that you know, try networking, because maybe by creating like actual links with people or opportunities to speak to them and show your passion and your ability and your work ethic through talking and asking questions and, you know, doing your research before you talk to people and knowing what you're talking about, having a clear idea of, you know, your interests. I would say that that is probably the best way to kind of try to shine through, if, you know, on paper it's not, maybe it's not as representative. Does that make sense?
Yeah, it's very thorough. And well, is it all right if we go with two more questions and then we'll let you go?
Absolutely.
Okay, we have Martina. Martina, if you want to ask, that second question that you sent was very good. So go ahead and unmute yourself.
Hey, so first of all, thank you for being here. It really means a lot. And then my question is, which careers would you advise us to study if we're interested in working in NASA? And if there are any specific universities that are taken more into account than others?
Oh, that is a very good question. Okay. Yeah, thank you for that. I would say, okay, in terms of the first part was like what to study, right? And I would say, you know, there are some obvious ones. Engineering, generally anything in STEM, is a good way to get into a technical career. But the thing is like NASA is a huge organization, right? We don't just hire engineers. We also have managers, we have outreach, we have even people who work on the side of like business development or business collaboration with, you know, any multitude of partners. We have people involved in policy, obviously, because that's how NASA gets funded. Education, even, you know, communications, writing. I guess like this is also to say that NASA is, you know, a huge organization, and we hire a huge number of people from all disciplines. I think ultimately, you know, I would really encourage everyone to find what they want to do first. Figure out, you know, what you're passionate about and what you really enjoy, and if that's, you know, science communication, or if that's data analysis of wind tunnel data, or if it's, you know, biology and the idea of supporting life in space, or even growing plants in space. Whatever it is, I would encourage you to like find your interest first, and there's a pretty good chance that it will match up with something that NASA or more generally anything in the space exploration field is working on. And then, okay, sorry, the second question was, oh, which universities, right? So I would say in general, as a general rule, I guess, like, there's no like list of universities, you know, that NASA hires from or doesn't. There are some that NASA has partnerships with, which is something that you could look into. And the main reason for that is that, you know, if there are universities, and they're generally the ones like in closer proximity to a NASA center. So for example, maybe like Virginia Tech and Langley, or San Jose State and NASA Ames, is that the thing about geographic location is that there's more likely to be potentially like professors, faculty, or graduate students, or even undergraduate students who work on or work even in partnership with like a NASA center. And so there's a potential for, if you're part of those universities, there's a potential for you as a student to also get involved. But the thing is, like, I also wouldn't say that it's confined to those universities that are like next to a NASA center. Like NASA has a lot of partnerships with a lot of universities, and they often have competitions that students from a lot of universities take part in. So there isn't really like a definitive list. I would say like you could look into it to see maybe like if there are obvious partnerships, but in general, like you should be able to find opportunities to get involved from any university. So again, I would encourage you to look at other factors first, like whether you like that university, whether the culture is right, and whether you fit in, and whether they're you know, researching in or teach things that you're interested in, and use that first. And then you know, I feel like for anyone at any university, there should be opportunities to get involved in you know, you can find ways to make that happen. So.
That's great. And before we let you go, there are some students in Nevada here in the United States that wanted to know, where do you see space exploration going in the next 10 years? And that'll be the final question before we let you go.
Yeah, that's also a very, very good question. I really hope, I have a lot of belief in the Artemis program. Is one of the reasons I really wanted to work on projects within the program, because I think that a push for more human exploration is really, really important. I mean, it's obviously like deeply, deeply inspiring, but aside from that, the kind of science and the kind of insight and the kind of technological progress that we get from sending humans out to do the space exploration is absolutely massive, and the benefits to society are also entirely there. So I have a lot of hope that things like the Artemis program and the Gateway program beyond it will start to really like make space exploration the norm, and will, you know, massively increase the amount of knowledge that we have about the moon and about Mars. Beyond that, I also, you know, I think robotic exploration is also extremely important, because there's definitely limits on what we can do with space exploration, and it's of course like exponentially harder to support, you know, human lives out there. And so when we're looking at you know, exploration of the deeper solar system, or even like beyond the solar system, and we're really getting into like astrophysics or cosmology concepts of like the wider universe and what we can measure, you know, things like telescopes, and as well as rovers and you know, autonomous machines is going to be also absolutely crucial. And then I think the last thing I'll say on this is that, again, like I think the trend that I touched on before, which is that, you know, NASA used to be kind of a monolith in space exploration. And since the 60s, like it has, you know, the efforts in space exploration have multiplied, they've become much more diverse, and it's become much more of a global endeavor. I think that will continue to be the case. And I think we'll see a lot more activity, you know, from countries that aren't America, aren't the USA, getting involved and, you know, contributing to our knowledge and the efforts there. So I think that's probably also another very big thing to look out for in the coming decades.
Well, thank you again so much for taking the time to educate and inspire so many students around the world. And before we let you go, I'm going to unmute everybody so we can all say thank you to Lucy for taking time out of her day, because I can imagine the stuff that you do on your day-to-day. And so we'll say thank you, and then I'll end the meeting for all. So can we all say thank you?
Thank you.
Thank you.
Thank you.
Thank you. Bye.
Thank you.
Thank you.